Alright, welcome back to our slides on files. We're going to finish them up today. So, we learned pretty much all there is to it. We learned about OF streams, how to write to files, IF streams, how to read from files. I just have a bunch of examples today for you, and I will give you first a little fun idea as to how I want you to imagine files are being read. Alright, I think this will help when you're writing programs with IF streams. So, think of it this way. Every time you open up a file, like here's your sample file, every time you open it in an IF stream ready to be read, it kind of puts a little cursor right at the start of the file. Like, you know how Microsoft Word or Google Docs use that cursor to think of where you're currently typing? That's kind of what it's doing too. Right? It starts a little cursor at the start of the file, and then every time you read into a string variable, it skips over any white space and reads what it needs to read, and it puts foo, the next word, into your S variable, and it moves the cursor so that it doesn't come back and reread foo. All right, that's something that's not obvious, but that's how it needs to work, right? It needs to know how much it's read so far, so it doesn't revisit what characters it's already seen. So that's what happens every time you read from a file secretly. There's a little mini cursor somewhere in memory, and every time you read another string into, it's going to read a word, right? If you're reading into a string variable, it'll skip over any white space, like that new line there, and then read the bar into the S variable. And you can imagine what's going to happen the more times we do this, right? So it's going to, next time I try to read a string, skip over the white space, read baz in the S variable, and then the very last time it skips over the new line, reads blah, and puts that into the S variable, and leaves the cursor right after that H. Okay, so that's how I want you to imagine things are happening when you're reading from an IF stream. That's how it knows, kind of how it knows when it's done with a file, and also where it is, what it's already seen, so that it does not come right back to where it was. We don't want that. So yeah, let's talk about that, and also that idea of EOF, end of file. Right? That's a method on IF streams that we could check to see, has it seen the end of the file yet or not. It'll be true if it has, and false if it hasn't. I'm going to show you something. It's going to be a little weird. It's going to end up being the case that even if you do this, if you read 4 strings, you would think that this cursor right here is at the end of the file. It is not. All right, that's a very weird thing. So I want to show that to you. Yeah, it's going to be weird. We tend to fix this problem by using a while loop like this. All right, we tend to use like this. We say while, ifs, read a word into a string variable. This will solve the problem because it'll fail. It'll notice that it failed its last read. But secretly, if you're going to do it this way outside of a loop or something, you have to read one more time. You have to have one more of these lines, and it has to fail. It won't fill anything into S. It just needs to fail, and that's when it notices the end of the file. All right? So that's the secret. I'm going to give you an example in just a second, but I do have to say the words first so that you understand the example. So yeah, it's just the idea is if you try to read past the end of the file, your variable, the second you do that, it's not going to get changed to anything. You're going to get a copy of what you had before. And this is what happens when you read the last word in the file. It puts your cursor right here. You ran these 4 lines, it puts your cursor right here. It does not actually notice that you're at the end of the file yet. You have to try to read one more time. That's what I'm trying to say. All right, it's a little complicated. You have to try to read one more time, then it will notice this and fail. All right, but the cursor's sitting right there after you read the last valid thing. So you have to read one more time and it won't work. Okay? So here's what I mean by that. Let's make our sample file. So we have something to read. It will be this foo bar baz blah. And that can be our sample file. I guess I used a dash in my example, so let's use that. There's my sample file, and with that, we're going to read from it. Okay? We're going to read from that in a new file. I'll call it eof.cpp. So we need fstream to have an IF stream. Oops. And I need string stuff, so include the string library. So I would like to open up this sample file, ifstream, ifs, and I'll just use the constructor to open up the sample file.txt that I just saved. So there it is, along with some other sample files I'll get to soon. But there's the sample file I want to read. It's open. I eventually need to close it. Can't forget that, right? And yeah, here's what I was saying. So let's make a string S, and let's read from this file 4 times. ifs read into S. 1, 2, 3, 4. It will get the foo first, then the bar, then the baz, then the blah, right? And so blah on this last line, blah is sitting in S right now. And if you ask IFS, hey, is the file over yet? ifs.eof, like what is that? It will tell you no, surprisingly. That's a little weird. That's why I'm having this example. Boop. It says false. No, the file is not actually over as far as it's concerned. It's got this little cursor right there. It does not actually notice the end of the file yet. You have to try to read one more time. Try to read one more time, okay? One more time, and then it will finally notice the end of the file. So here I am trying to read one more time, all right? And this is the line that's going to fail. It's going to notices the end of the file, and the read fails. All right, so now ifs.eof will be true, okay? See where I'm going with this? It will be true, and then this line failed. It'll run, but it's going to fail. What does that mean about S? Like, what's in S right now? It's still blah, all right? So you might expect this last line, which failed, to mess with S. It will not. It's just going to notice the end of the file. And do you see how if you mess up with the way that you do things, like you're reading versus checking EOF, you might think that there were two lines that said blah, because right here, if I print S again here, you might think that you read blah twice. Do you see that? Like, all right, on this read, I got the blah, and then on this other read, I also got the blah. Do you see if you forget to do the EOF checking after you read, it's got to be after you read, then you're not sure if it failed or not. You might think that, oh, I saw blah twice. That was just what was in my file. When in reality, no, there was just one. All right? See how that's a little subtle? That's why I'm having this slide about it. So you have to read one more time to notice the problem, and the read will fail, and it won't update the variable. This while loop just solves everything for you if you do it this way, which I encourage you to do it this way. But if you do a read and check kind of deal, you have to check after you read. All right? Only then do you know if that read succeeded or not. All right? I hope that makes sense. So that's my spiel for that slide. And now I just have some silly examples. All right? So I would like to translate the lyrics to Let It Go by the people in Frozen. So I have for us the lyrics right here is Let It Go, lyrics.txt. Here they are. Snow glows white on the mountain tonight, all the way to the end. So that's the file. I'd like to read that file, and I'd like to translate some words in the file. I think that will be fun. Okay? So that's my goal. I want to read all the lyrics in the file and translate some of the words. We're going to need to mess with white space characters because I want to keep it looking pretty like this. Not just getting words and like spitting out words with spaces in between, but like we got some stanzas going on here with like new lines and new lines after new lines. It's pretty cool looking, so I want to keep that. And I'm going to need two functions in IF streams that I have not talked about yet. So let's go and look at them. So here's the IF stream type. In every IF stream, you can check for EOF, do stuff, right? You can read into your variable with your operator greater than. Some other cool stuff that you can do is, where is it? You can get and, where is the other one? You can get and peek, all right? So get and peek are two methods on an IF stream, and what they do is they work on a single character. They're going to give you back a single character. Forget that it says int here. It means character. It returns back a char, and so does peek. All right, they're both going to give you back the next character in your file. So here's what I mean by that. So peek and get, they're going to give you back the next character in your file. If you say ifs dot get, what will happen? You just call it like that, and let's say that this is your file. You're on this line, or here, let's say that this is the line you're on, and like here's where the cursor is. It's about to see the B. ifs.get goes and gets the next character out and it gives you back the B character. All right. It also moves the cursor. It eats it up. Eats up that character. That's how we say it. And then the new cursor is sitting right here before the L. Okay. I hope that makes sense. So that's what get does. ifs.peek works similarly. ifs.peek right now that I read the B, it will give back the next character. It will give back the L character. But the difference is that peek does not move the cursor. It just peeks ahead at it, does not eat it up. All right. So this one doesn't move the cursor, but it gives you back the next character still. Doesn't move the cursor. So if you call peek a bunch of times, the answer will never change, but if you call get a bunch of times, it will move on. Okay? So we're going to need that to preserve white space. I'll show that to you. But yeah, let's translate the lyrics to Let It Go, because why not? I think it's fun. So here, let's make file. I guess I want to call it translate.cpp. And I mean, I want to read from files, so let's steal a lot of this code from right here. So I've got a string, or I've got a file. I want to close the file eventually. So there it is. And it's not called sample file, it's called, what was it? Oh yeah, it's right there in the corner. It's let it go lyrics.txt, but I'll put it there too. Let it go lyrics.txt. There it is. So now we're opening it. Got to close it eventually once we're done. And yeah, let's walk through it. So I want to read a bunch of words out of this file and print them back out, having translated them. All right, if that makes sense. So here's kind of like my setup. Like I want to get a bunch of strings, like every word in the file, read them in one by one. So while I can read from IFS into the word variable, read every string in the file, read every word. So every time this body gets run, I'll have a new word to mess with. And then what do I want to do with each word? I would like to translate it. Translate that word, give me back a new translated version of that word, and then maybe, I don't know, I'll put a space to space them off, space them between each other right now, but I'll fix that soon. Okay, that's my goal. That is the program. So yeah, it's just going to read every word in the file and call the translate function on it. And what I want my translate function to do is take the word, string s, and give back a new word with the translated version of that word if I know how to translate it. Okay, that's my goal. And this string, I just want to look at it, not mess with it, so I'll take it by constant reference. Okay, so let's say we only know how to translate one word right now. If we were in the in-person class right now, I would be asking you guys, like, what languages do you speak? Let's translate some of the words in this program, or in the words in this file. And let me just make up examples now. I assume that a lot of us speak Spanish in this class. So let's take snow, and let's say we know how to translate snow. If you ever give me S being snow, I will translate it to Spanish and return back nieve, right? So if S is snow, then the translated version of that is nieve. All right? And then let's say that that's the only word we know how to translate right now. Otherwise, if we get any other word, just return back that same word. We're not sure how to translate it yet. Okay? So that is my story there, and I think that is a good idea. So let me show you the program running so far. If I compile and run. It's going to read the file. Each word in the file, it's going to shove into this translate function, which will return back either a translated version of that word or the same word, and then it will just spit them back out with spaces in between. So look at it go. It's a little ugly. It's all in one big paragraph now, but it says, the nieve glows white on the mountain tonight. Isn't that cool? So before we make the translate function cooler, I think you see an issue, right? This does not look like the same file. I mean, the words are the same, but that's all I've done is I've skipped over the white space and just like inserted spaces instead of like the double new lines between the stanzas. Like all the pretty stuff is now gone. So instead of outputting a space, what I'd like to do is preserve whatever white space there was. Like maybe I just read queen period as my word. My cursor's sitting right here. Instead of printing a space between that and the next word, I'd like to peek ahead, right? I want to peek ahead, see that there's a new line there, and then preserve that new line. Now I'm down here. And then peek ahead again. Oh, see, there's another new line. It's white space still. Preserve that one. Now I'm down to the t variable, or the t word. Okay, that's what I'd like to do. I'd like to peek ahead. Don't do it like that. Don't like say what it should be. Just keep what was already there. So I want to preserve all the white space after this word, whatever it was. Okay, that's what I would like to do right now. And so here, how do you do that? Well, you're going to use peek and get. All right, peek to look ahead, see if it's white space or not, If it is, get it, eat it up, and preserve it. Does that kind of make sense, that two-step process? Because we have to like eat it up, move the cursor, so that we're ready for the next real word eventually. Okay, yeah, let's do it. So here's kind of the goal. So like while looking ahead, there's white space. So is space is in CC type, right? CC type. While looking ahead, ifs.peeking ahead, looking back at that character. So that'll give me back the next character. It'll look ahead but not move the cursor while that is a space. So while is space is true for it. ifs.peek, give me that next character. What do I want to do? So that this is confirmed. The next character is a space. Like as long as that's true, what do? I want to eat it up, advance the cursor over that space character, whatever it was, the space, tab, new line, and then also output, preserve that space character, output that same white space character. Does that make sense? So that's the two-step process. So give me that next character, whatever it was the same as ifs.peek, so I could call that again, but I also want to eat it up to move on. So I'll just call ifs.get to give me that next character again, and then also move the cursor. And then I will just preserve it in the output by saying cout, whatever that was. Was it a new line? Who cares? Was it a space? Who cares? Just keep on doing that as long as you've got spaces. Usually there's just one space. It's like after there is one space. Preserve that one space. But sometimes there's something different than a space. Like after tonight, there's a new line. It will notice that and preserve the new line. Keep the stanzas. After queen period, there's two new lines to get to the. See it? So that is what this loop is going to take care of. It's going to preserve things. Isn't that neat? I think that is what I wanted to say there. So here, so we recompile, rerun. Look at that. It's got all the stanzas in there now. Now it's the nieve glows white on the mountain tonight. Okay? So let's do some more translation words. This would be fun. Even more fun in class, but I love to learn languages. So here, let's do some other examples. So else if s is equal to some other word. Let's try something. Let's do a different language. Let's say nouns are usually easy. Let's do, I don't know, kingdom. Let's translate kingdom to another language. Kingdom. We can translate it to French. How about that? I think it's like royaume or something like that, but I will use Google Translate just to make sure. Kingdom. Did I pronounce it right? I'm not sure. I just know how to read French, not how to pronounce it. So yeah, if it's kingdom, it's that. Royaume. So I think I can hear it if I click the hear button. I don't know if you're allowed to. Royaume. Yeah, cool. Sweet, I'm almost right. So if we say kingdom, we'll do that one. And then just to show you something cool, let me show you that C++, if you put it between quotes at least, it can handle any kind of character. So let's do another, nouns are the easiest. Mountain. Mountain, if S is mountain, well, let's output mountain in Japanese. How about that? And that is mountain. That is yama in Japanese, but it has a special Chinese character, this one. You can, if it's between quotes at least, you can preserve that same Chinese character. That's pretty cool. So here. Now we got a cooler translation program. Let's take a look. So now it's the nieve glows white on the yama tonight, not a footprint to be seen, a royaume of isolation. Beautiful, right? So that's just a fun fact, now you know. But I hope you understand this program. What we're doing, we're reading a word at a time, and getting the next word. As long as we have another word to read, I want to translate it as best as I can, according to my translate function. And then whatever space is after that, eat it up and preserve it. All right, as long as there's space, while. And so this just became a doubly nested loop, but it made sense, I hope, why it needed to be a doubly nested loop. Okay, and I think that's the story. That's all I got for you for that example. I hope that was cool. I have even cooler ones next, but yeah, just yell at me if you have any questions about this stuff. So that's files. Here's a cool one. Let's do a program that we maybe have used already. I want to make a program that pretends to be the copy command. All right, have we used this one already? It's a command. This is technically what's happening when you use gimme in when you're doing your labs, if you've never used it yourself. But the CP stands for copy, It's a terminal command that will copy one file name into another file name. So it takes, like you say, copy file 1 into file 2, and it will take file 1 and make a new version, a new copy of it called file 2 in your same directory. So I want to make my own version of that. I want to be like /cp and give it two file names, file 1 and file 2, and it will open this one for reading and this one for writing. Does that make sense? That's all we have to do. We can make our own version of this cp command, this copy command. So we are forced, if we want to run it this way, we need command line arguments, right? So where is this one, right? Where are the two file names? It's argv of what? This one's argv of, drum roll, do you see it? This one's 0. The name of your program is always 0, so this is argv of 1, and this is argv of 2. Okay, those are my two command line arguments. And so I'm going to need one IF stream to read this file and one OF stream to write to this file. Does that make sense? That's what I need. And we'll just do it, whatever characters were there. We'll just do character by character, preserve each of them. There's ifs.get to read a single character, and then output file streams have a .put, which is the opposite of get. It writes a single character into the file. So you can go look up that on the documentation. I hope it's not too horrible, right? Just like put a single character into the file. It's the opposite of get for IF streams. So yeah, let's do the cp copy command. I would like to be there. So I'll just call it cp.cpp. That's a fun word. So here, I would like file stuff. So can I just steal one of these? Yeah, I'm gonna steal this one. Boop. So let's get rid of most of this now. Yeah, let's just have a blank slate, but I have all the file stuff included. That's what I really needed, right? So if I want command line arguments, I need to do this. Int argc char star argv bracket bracket. So argv is an array of C strings. We're very comfortable with that now, I hope. So yeah, what does that mean for us? We care about the two file names in argv1 and argv2, and it just so happens that if you use string variables, like input file name, you can shove a C string into a C++ string just fine. It's happy. It will convert it. This was a char star. It will convert it into a string if you assign it into a string. It's okay with that. All right, so that's what we can do. Output file name is an argv2. And then you really should be checking argc to make sure those exist, but let's just pretend that the user called it right, ran the program correctly. And so now my goal is to read the first file and write to the second one. So I need one IF stream hooked into the input file and one output file stream hooked into the output file. Does that make sense? And then once we're done, we have to close both of them. It's always good practice to do that. And then the magic happens in between. So what do I want to do? I want to repeatedly get a character and write that character. Get a character from the input file and write a character to the output file, because we're preserving each individual character. So let's make this an infinite loop, and we'll do it the EOF way. So what I want to do is this. I want to read one character, read a character from IFS, and then, just like I told you, we better make sure after each read, if we're going to do it the EOF way, we better make sure, did that read succeed or not? We have to check EOF after every read. It's after every read, not before, after. All right, because the read itself causes the failure. It causes it to notice that you're at the end of the file. So then after, order is very important here, we make sure we got a valid character before we write it, because our job is to write and preserve what character that was. And then, yeah, if we're still here, we'll break out, I guess. We'll break out of the loop if this is invalid and the first file is over, then our job is done. So if we're still here, we'll put the character into OFS. That's our goal. Okay? So yeah, let's do that in that order. So let's get the character out of IFS. ifs.get, eat it up, get ready for the next one. And then if this was successful, EOF is still false for the file. So if we hit the end of the file, ifs.eof, if that's true right now, all right, so equal equals true, remember that is redundant. So if we're at the end of the file right now, then we better stop, because this read failed. We got a random value in C. It did not count. Okay, so that'll break out of the loop. All right, if we hit the end of the file, if the file is not good anymore, technically, because IFS itself can be translated into a Boolean, you could have said like if IFS is not okay anymore, if it's not true, if not IFS is true now, the negation of it. Does that make sense? So that would also be a good condition here. So there's that. And then if we're still here, if we did not break out, that means the character was successfully read. It was not at the end of the file yet. Did not notice that. Then take that character and shove it into the output file. We put it. That's the opposite of get. Okay? And then after we're done, both files are over with. We can close them both, and we're good to go. So that's the relevant part of the code. I hope that makes sense. Oops. So we've just made our own copy command. And which file do I want to copy? I guess we've got here we've got the sample file.txt. It contains the following. There's my sample file, and let's watch our program copy that. Copy the sample file.txt, and I give a new name. I'll call it, I guess, sample file copy.txt. Hit enter. I get no output, but it made that file. See it? And if you print that to the screen, you get the same stuff. That's beautiful. All right, so that's that program. I think, yeah, that's most of it. So remember the close is below that, but this is as much as I can show you with this zoomed level. But yeah, that's, I think, a useful example. We've just made a terminal command that we've used a lot, potentially, or has been used for you, at least in the gimme command when you do your labs. So yeah, that's pretty fun. What next? What next? I think just next I want to talk about a fun type that is kind of like CIN and COUT and IFS and IF streams and OF streams all together jumbled in one. It's called a string stream. It is a type. It lives in, I assume it's here. It lives in the S stream header, and it's a type called string stream. All right. It derives from a bunch of weird stuff. Okay, it derives from IO stream, which is apparently also a type rather than in addition to a header file. What can you do to a string stream object? You can give it stuff, you can extract stuff, which is weird in itself, and then you can, it's just essentially building up a big string for you. Here's a string stream, you can fill it with stuff, you can extract stuff out of it that you've put into it. It's just really cool, all right? It's useful stuff. So here, a string stream, it's kind of like your own personal CIN, COUT, or file even, all right? So you make one by saying string stream SS, or give it a name. It's just a variable name at that point. Call it whatever you want, semicolon, and that creates like your own little personal file, or really just a string, kind of. So you can build something up inside of it. You can build up a string inside of a string stream. Like if you say it like this, it starts empty. You can put stuff into it, and you can get stuff back out of it too, and convert types, because like it's all stored as a string, usually. So this is the header file that's in, and let me just show you an example of it. So like when you say string stream SS, it creates like your own personal string. It's like working on a string or a file. And then you can give it stuff. You can like, hey, give it an int. And then it will put as characters, it will convert it to characters. It'll put 100 into your string stream. If you say new line, it'll break the line. If you say give it 200 now, it'll put a 200 there because you broke the line, right? You can do that. You can give it stuff, and it's built up this string essentially now. All right, 100 new line 200, the characters, and you can also get stuff back out of it, which is wild. This actually used to be the way that you had to. This was the only way that you could convert text to numbers, or numbers to text. Excuse me, numbers to text in C++ before the toString function got made. Like you had to use a string stream before. So that was a nice historical fact, but it's still useful. Like you've put something in, you can get it back out. Like make an int variable, take it out of SS index, because like when you're reading, there's that cursor, right? The cursor's at the start of your file or your string or whatever this is of your string stream, and you reading one int will skip over white space, read an int, put the cursor after the int that it just read, and now X holds the 100 as a number again. Isn't that weird? That's pretty cool. And then at any point, like it doesn't get rid of the 100 either, it's still in there. At any point, if you want the string that you have built up in your string stream, you can say, where is it? .stir. You can ask for the .stir, and it will give you back the string that you have built up. So if you say ss.stir right now, it will return to you the following string. This is what I put into it. 100, new line 200. It's going to give you back the string 100, new line 200. I hope that makes sense. So that's what strings are all about. Let me just show you that. You might need it one day. It used to be the way that you converted anything into a string. It's like you can just give it to it, like a cout or like a file. So if I want to use it, I want to include stream. Okay, and so make a blank one, string stream ss. Call it whatever you want, and then I'll give it 100. I'll give it a new line, and I'll give it 200, and as you're doing that, it's building up a string inside of SS. It's building up, like after this, SS now holds the string 100. After this one, now it holds 100 new line. You just added a new line. And then after this one, after the 200, it now holds 100 new line 200. Okay, that's what's there. And so you can always get stuff back out. You can say int x read out of your string stream into your x variable, and like it will give you back the 100. You can also get out the entire string that you built up, so I'll show you that too. Oops, so there's the 100, and then also you can get out the entire string and be like cout ss dot the entire string I built up, which still has the 100 in it, by the way. Reading it out does not change anything, so it's still there. There's your string, and we just printed it back out and put a new line at the end. Okay, so it's building up a string, and you can get stuff out of it too. It's really cool. Your own personal CNC out kind of / file. That is what a string stream is for. You might need that one day, and now you know. Okay, so with that, I have a fun example for you. I really would like you to pause the video and try this. It's a really cool, fun one, I think. You know, you've been to IKEA, perhaps. You know that at IKEA, they have very weird names for their products. They essentially just take random Swedish words and string them together and make compound random Swedish words, and that is the name of their product. And like everybody goes and buys it because it sounds fun. So what I'd like you to do is pretend you're IKEA and you've got the new hot product of the season ready to go, and you need to think of a name for it. All right, so I have given you, if you go to the code from class for today, download this file. It's called swedishwords.txt. It has the like 1,000-ish most common Swedish words. Here they all are. What I'd like you to do is make a program that reads all these words and randomly picks 2 of them, shoves them together, and generates a random Swedish compound word, okay? And that could be used as an IKEA product name. So I want you to generate IKEA product names from a list of Swedish words. And so there's the file. Go to the code from class. It's in there. Read that. Read every word of the file. And a good strategy would be like make a vector of strings. Read every word in the file into a vector. Like here's every single word in this file. Word A, first word, B, C, blah, blah, blah. Let's say that these are my example words. Like you got a big long vector, 1,000 long. And then what I want you to do is pick 2 random ones of these. Pick 2 random words in this vector by picking random indices in it, all right? And let's say that randomly you get like, okay, go to index 1, then randomly go to index 3. So you'll take the 2 things there and shove them together. And like you'll produce BD as your hot IKEA product name, okay? Does that make sense? So just pick 2 random words from this file and shove them together, and that will be an IKEA product name, okay? So please try that. I think it's really fun. It's a silly idea, but it's convincing and it's different every time. Like maybe you'd buy that product. Maybe it already exists. So yeah, give that a try. And then now that you've tried it, I would like you, I would like to try it too. So I've got this file. I'm going to read every word in this file, swedishwords.txt. So that's name down there. And I want to read a file. So where's a good, I'll go back to my EOF file to copy just a file that's reading stuff. IKEA.cpp. It's so silly. So, alright, so I'm going to read, what's it called? swedishwords.txt, and eventually close it. Good. And what I'd like to do is make a vector of strings. So I got string, I need vector too. Vector of strings. I'd like to make a vector of all the words in this file. Vector string words, and then I want to read every word in this file. Read every word in the file into words, and they're all white space, they're all new lines separated, so I can do my while loop game. I can be like, while I can read from IFS into like a word variable, I'll make that. Read a single word at a time into there, and be like, words.pushback. That word that I just read. See that? That'll fill it up with every word in the file, or read every valid word in the file, and get them all in there. And actually, at that point, I'm done with the file. That's when I can close the file. I don't have to pick random words yet. Like, only after that do I need to do that. Like, the file is done with. I don't ever need to touch the file again. I can close it now, and then I can pick my random words. So, get 2 random words out of the vector. All right, that's my goal. And so if I want to do random stuff, right, I need cstdlib for rand and srand. If I want it to be different every time, I got to seed my random number generator with the time, nc time. And so it's srand times 0, right? That is the magic. That's the incantation that we have to do to make sure randomness is different every time. And so yeah, now that I've got my vector, I just want 2 random indices. I want to like go into the words vector at a random index. And how do you get a random index? Well, you say rand to make a random number, and you got to shrink it down to be between 0 and the size of the vector minus 1. Do you see what you could mod by to get that? It's just the size of the vector. What are the valid remainders after dividing by size? It's 0 all the way to size minus 1. That's perfect. Those are all valid indices. That's exactly it. So there's going to be a word, and that can be my word 1. Word 1 is a random word, and word 2, same deal. Just like go into there to another random index and output them both together without any spaces as a compound word. And that's the new hot IKEA product name of the season. Okay, there's the relevant code. Do you see it? And there you go. I won't even pretend that I can pronounce these, but like that seems like a product name. Maybe I'd buy that. Yep, for sure. That could go in my kitchen, right? And it's just fun. I hope that you enjoy this too, and you share your convincing IKEA product names on Discord. Honestly, some of these might already exist, for all we know. Beautiful. All right, so that's my next silly example. And for my last trick, I would like to do something super cool. It's one of the coolest examples I can give in this class, I think. It's I want to work with images, because what are images but files? All right, so I'm going somewhere cool with this. Normal images like JPEGs and GIFs and PNG files, they are complicated. They're like compressed, they're binary, they're weird. There is a file type, though, that's easy for CSCI 40 students. It's just a text file. It's called a PPM file. So if you go to the Wikipedia page, here's what a PPM file looks like. It's just text that corresponds to, it tells you all the pixels in a file, okay? So we'll talk about that in a second, but like this is a kind of file, and this will correspond to this exact image with 6 pixels, like the first one's red. Like this is what it looks like. So I'll get to that in a second. But before we get there, I want to mess with image files, so we better learn about images first. So first of all, do we know, hopefully we know by now, that every picture, every digital image at least, is made up of a bunch of square pixels of a certain color. So like if I zoom in on my screen, it's close and close enough, for some reason it's making it, it's kind of silly that it's doing that, but I think there's some weird default to this that I cannot mess with. I don't want you to do that. I don't think there's any options anymore, but take my word for it. Take a magnifying glass on your screen. Just look really close. It's just a bunch of squares. All right, it's really just a bunch of square pixels of a single color. And so there's just a million pixels in your images, and every pixel is a single color. Every pixel is just one color only, but because they're so small, it looks like it's all perfectly aligned and like a gradient. But every pixel is really just 3 numbers. Every pixel is a single color, and every color inside of a computer, in general, so the standard way of doing things, is to use 3 ints between 0 and 255. They could have been chars, I guess. They're all 1 byte long. So between 0 and 255, and you get 3 numbers to represent your color. And each piece of that is a number between 0 and 255, and it corresponds to how much red is in this color, how much green is in this color, and how much blue is in this color. The 0 means no red. 255 here would mean all the red, as much red as possible. All right, so that means like the pixel red would be the numbers 255, 0, 0. Max red, no anything else. All right, this is called the RGB color system. How much red is in the color, how much green is in the color, how much blue is in the color. It's kind of like light, it's additive, so that like it's not like crayons where if like you give max red, max green, max blue, it makes like darkness. It makes garbage looking colors or black. No, it's like light where if you give all of each color, 255 max of red, green, and blue, you get white. All right, so that creates white, and that means 0, 0, 0, none of each color creates black. All right, and like 255, 0, 0, that's red. I think you can imagine what green is, what blue is, and like all their combinations, like red plus green apparently makes yellow. That's weird to me too. It's not like paint, it's like light. All right, so that's RGB color theory, and yeah, just in general, your pixels look like this. It's how much red, how much green, how much blue is in this color that we're talking about. And you can kind of extrapolate from here, like 0, 0, 0, like when they're all the same, it happens to be, just like for black and for white, if red and green and blue are all the same amounts, that creates a shade of gray. It's perfectly neutral. So 16, 16, 16 is a very dark shade of gray. 95, 95, 95 is another shade of gray. All right, so there's 256 shades of gray in RGB colors, if you count black and white at least. So yeah, that's the format, and here's the files that we're going to be using. It's ppm image files. All right, it's a file type that stores images, and it looks like this. It's the first line, you can have comments in the file, which is kind of cool. You say P3 means it's a color image with a certain version of the ppm format. Like the first line is always P3, and then the next meaningful line is the width and height of the image. Like this is a 3x2 image that it's trying to say here. And then you say, what is the max value for all these pixels? And we just want the normal RGB format, so 255 is the max. So like these three lines, P3, your width and height, and 255, those exist for every file. Though the width and height, of course, change. And then you just start giving pixels, as many as there need to be. Like there needs to be 6 for this one. You just start giving them in like row order, okay? And that's an image. So I've made a ppm file. Here it is. It's called cat.ppm, and let's look at it. It's just a very large file. It's got 500,000 lines, but it's exactly that. It's P3 width and height, 255, and then it starts giving pixels. And these are pictures of my cat. This is one picture of my cat as a kitten. All right, you need a special image viewer to look at it, by the way, but it's not normal. You can't open this normally in Windows, but it is an image file. If you click it and you open it up in an image viewer, it will take this stuff and draw it on the screen for you in the way that it's supposed to be. And like here's a picture of my cat Lonzo as a kitten on some colorful running shirts of mine. So we're going to do some fun stuff with these. All right, we're going to mess with this image and change it and modify the pixels in it. All right, that's going to be my fun example for the day. So okay, that's just a file. It's really like this. It's really just a text file. We can mess with it. All right, that's what I want to do. So here's my ppm file. We give it those things as text, and so that's easy for us as CSCI 40 students to mess with and work on. So here's my goal. I taught you all this for a reason. Let's take our image, let's read it in, read all the lines of this. Like we have to preserve these 3 lines. We're not going to change the size of it or anything. But then we're going to get every pixel and we're going to mess with each of them. I'll put a different pixel. So what we'll do is let's make it black and white. Let's make it a grayscale image instead of a color image. All right. So to make it a grayscale image, if it was red, we got to turn it into like gray, a version of gray. It's got to be like, they all have to be equal to each other to be a shade of gray. And so what we'll do is one way to get how like what does gray mean? It just kind of means how light was the pixel, how dark was the pixel. Hopefully you kind of see like bigger averages for red, green, and blue make white or closer to white, and lower averages are closer to black. And so like average can be what we do here. So given a pixel with a certain amount of red, green, and blue that's like colorful, we'll compute the average brightness of each color channel, we say. So like take the red, green, and blue and average them together, and then we'll convert this pixel into just average, average, average. Does that kind of make sense? It's like we're computing a lightness value based on that. And this is now a shade of gray. We'll just replace every pixel with its closest brightness value with this kind of calculation, and it will turn my colorful picture of my cat into a black and white grayscale version of my cat. Isn't that cute? So let's do that. So again, here's what the file looks like. Looks like that. And I would like to take that file and mess with it. So I will call it, what do I want to call it? I'll call it gray.cpp. So let me steal that file processing file, and I'll do this. So I need an IF stream and an OF stream. I'll get to that in a second, but I just want to always remind myself which image viewer I have to install in order to like view this on my screen. On Windows, if you want to look at PPM images as actual images rather than text files, just in case future me doesn't have it installed, it's a program called Irfan View. All right, to view PPM images, at least on Windows. Other kinds of operating systems need a different program. This Irfan View program is only for Windows. So yeah, I can help you view your own or convert your own pictures. If you want to play this game with your own examples, I can help you. Just let me know. So what I want to do is open up its cat.ppm. That's the file I'm messing with. And I don't want to replace that file. I would like to save a new version of the file that's all grayscaled. So let's do an OF stream. Let's write into a different file. Call it like catgray.ppm. All right. And so I'm going to work with both of them and eventually close them both. So yeah, what I want to do, I want to create this grayscale version of this cat file. And so what I must do is here. Where is the file? There it is. Here's my cat file. I would like to preserve the first 3 lines. Those are just whatever they were. We keep them the same, and then the pixels start. So I want to keep these 3 lines the same. So I want to keep the same first 3 lines in the output image. That's important. I need to do that. And I spelled output wrong. So there's that. I've done that now. And so how do I do that? GetLine would probably be the easiest. Like give me lines at a time. Like getLine from IFS. That's fine. You can totally do it that way. Get a entire line just like you could get it from CN because they work the same, right? Into line, and just like take that same exact line and shove it into the output file with a new line because getLine does not take the new line. It skips that. So I'm just doing that 3 times. Preserve those 3 lines. Does that make sense? So that makes sure the rest, like the width and height, it's all in there correctly now. And then we come to the pixels. Okay, so now it's always three numbers, right? Red, green, blue, red, green, blue, red, green, blue, until the end of the file, even though it's 500,000 lines later. Like until then, like we're just getting 3 numbers at a time. We can always do that. So I would like to repeatedly, like in a loop, for however many there are left, repeatedly read RGB values and modify them in the output image. So I'll just make space to read each pixel, each color part. So give me red, give me green, give me blue. I've got room for those now. And just kind of like, I can do it like this. I can say while I can read from IFS into red and green and blue, and it all worked out. That'll always be true for correctly formatted files. Then I've got a valid pixel inside of the body. Convert to grayscale and add it to the output image. That's what I want to do. And so this is the process. Given my red, green, blue color, whatever it was, whatever my colorful color was for this pixel, average together to get the average brightness, and put them all together 3 times to make a grayscale color. So yeah, it's just average is red plus green plus blue over 3. We'll use integer division. It has to be integers. So there's that. And then what it'll output is, instead of whatever this is, it's the average 3 times with spaces in between. So it's into the output file goes average space, average, right? Average space, and then average one more time, and then a new line. And that'll be the format. Okay? And yeah, once you're done with that, that's pretty much the name of the game. So let me compile and run it, because it's going to take a while. So it's working. It's working hard right now, but let's go through it again. So we're open up the input file, and then also where we're going to save the file. It's still running. We're going to preserve the first 3 lines, because that's just like the image format, the width and height, the max value. Like we want it to all be this still. And then we're working on the pixels one by one. So I make room for each pixel, all the pieces of it, and then I read a pixel at a time. So like that'll read this first one, the next one, the next one, in RGB format, in order. And then after I've got those 3 values, if it succeeded, this loop will stop when the file's over, right? It'll stop when the file's over. If it succeeded, then we have a calculation to do. Let's calculate the average brightness value by averaging together the red, green, and blue channels. And like that, we can just say 3 times, and that can be the new pixel, the new average together brightness value pixel. That will be grayscale now, all right? And then eventually, like this will finish. We'll have gone through the entire file and output new pixel values, and we're ready to close them both, because that's the end of the entire process. You see it? And so it took long enough. We're back on the terminal now. So it did correctly make a new file. It did make cat-gray, and let's look at it. Let's look at it together. So there's the first one. catgray.ppm. So there we go. Let's see what I can do here. So they're going to be the same length. But do you see how this got turned into 23, 23, 23? This one got turned into 28, 28, 28, and apparently this one did too. That's what they average it together to be. And that these are now grayscale pixels all the way down to the end. Whee, same number of lines and everything, so it worked. And that's the file. And let's see how it did. So if we view this as an image in some program that knows how to look at PPM files rather than just as text. So I've got my cat.ppm, and now I have my catgray.ppm. So here's the original. And here's what we just made. Look at it. We did it. Isn't that cute? So yeah, you see that the brightness has been preserved, because like that's an average kind of calculation that we did. It's like average together. That gives you like a good approximation for brightness, and you turn that into a grayscale value. I love it. So yeah, just the relative brightness is all still there, more or less. That's one way to do it at least. And we have just made this file from this one. I think that's really neat. All right, it's one of the coolest examples I can give you in this class. So cherish it like I am right now. So yeah, I think that's what I wanted to tell you. If you're on a Mac, I'm not sure which program you need to install to get that working, but I can help you if you want my help. But with Windows, it's this Irfan view. Okay, so yeah, with that, I think that was my last example. So that is files in a nutshell. It's not horrible. It's very similar to CIN and COUT, and you know why now, because the types are involved. Like you got those I streams and O streams and things. So you know it at a pretty good level now, and you saw some cool examples, and I think that's all that I have to show you for these things, for this topic. So we're going to start some new slides in the next lecture, and I guess I'll see you then.